Again.
Catherine, habari. I gave you some notes on running cups. I did not give you any notes. What I gave you some notes. Okay, good. So here to Manisa. Now we then need to proceed and discuss something called learning curve methods. Learning curve methods. Oh, we solve a question, eh? Thank you. You can see I forgot it. So if we are solving a question in the past papers, then that question should be a question of September 2015. It should be a question of September 2015. Question number 4C. September 2015. Question 4C. And the question says that the finance director of Estimator Solutions Limited have availed to you the following data for a company. The company has a single manufacturing department. The cost data available relate to the last 16 months as follows. So we have the departmental overhead costs, direct labor hours, direct materials quantity in kilos, and number of orders processed. A computer program has been used to analyze the above data, and the results are as follows. So we have the regression, we have the dependent variable, the independent variable, the coefficient, the standard error, and the t-value. And we have all that. So before we even answer the requirements, I want us to develop those equations. Although they are not part of the requirement, the question has not asked us to do that, but some others will. So we have regression. We have regression, and then we have the equation. So if you follow regression one, you can see the intercept is, so it will be written as y is equals to 12, 0.52 plus 8.5 x1. You can see the 8.5 plus 6.95 x2 plus 6.59 x3. So that is how you can write equation one in case they had asked you to do so. Then for equation number 2, it will be written as y is equals to, the intercept is 12,190 plus 8.88 x1 plus 7.06 x2. And then equation 3. Equation 3, we will have y is equals to, the intercept is 16, 3, 10, plus the value there is 10.98. 10.98 x1. And then equation number 4. Equation number 4 is the intercept is 18,277. Y is 18,277. So you add 10.68. 10.68 x1. So if they had told you to write the equations, that is how they are written. That is how they are written. So this is a table of coefficients. It's a table of coefficients. Then if you look at equation 1, you can see the column of the coefficient and the column of the standard errors and the column of the t value. So chukua calculator and do this. For the first one, it is 8.5, so put 8.5, 8.5, and then you divide by 1.93, and check whether the answer you get agrees with the one that is given as t value. That's all? Yeah, because we said that t value is the t calculated, and we say it is given as the slope, which is the coefficient. You divide by the standard error of the slope, SB. Yeah, and the same can be confirmed for the others. I think that is what I needed to have said. Now, the question says, you tell us the most reasonable equation. The most reasonable equation. So what we shall do, we shall have something like this. We can just call it most reasonable equation. Most reasonable equation. Now that we have 4 equations with us, for us to say which one is most reasonable, we will have to test. We will have to test. And in testing, we will have to know which character we are going to use. Which character we are going to use. And according to this report that is given here, there are 3 things we can use. The reliability test that we did. So I can call them test of reliability. Test of reliability. Now in the test of reliability, we will first of all do number of independent variables. Number of independent variables, that is the first thing that we shall check. The next thing that we shall check that is given there is what we call adjusted R square. And then there is the standard error of estimate. Standard error of estimate. Those are the 3 tests that we shall perform. And I'm saying the 3 because these are the ones that we have information about. If you look at the report, we have their information there. We have their information. So, we will select equation, then we will have the reason or the explanation. Reason or the explanation. We will see why we are going for that. Equation 1 has how many independent variables? Huh? Equation 2, equation 3, and equation 4. So which one is best? Which one is best? Select equation. Select equation. So which one is the best of those 4? Do you go where you have many or you have fewer? For example, take that have come your way proposing for a relationship of whichever nature. And before you say yes or no, obviously we expect you to do some background check. So you go asking some people about me. So would you just ask one person, or you'll be comfortable asking many people who know me? Yeah? See, it is better you ask many. Yes. Why? You gather more information and you eliminate the possibility of the one person you ask is my good friend. And maybe as a friend, I have already briefed that I'm looking for a relationship with you. So when you finally go to ask them about me, see, they will tell you some good things that can make you accept my proposal. And that those good things may not be always true. But when you ask as many people, those people, the probability of one of them telling you lies is very minimal. Rather, all of them. Because there are some people who know me and they benefit from me with nothing. Is that so? So even if they were to say bad things about me, obviously which are true, and I happen to know that they said so, and out of what they said, my relationship has failed, they have nothing to lose. So for them, they'll just say what they know. But there are some people who are closer to me, they benefit from me, they know some bad side of me, but they fear if they were to tell you, and I happen to know that they told you, what they get from me would be no. So it is better you consult me. So it is better to go for equation 1 because it has the highest number. It has the highest number. Just a minute. Okay, so adjusted R square. The first equation has R square of what? R square of? The second one has? Then the next one? And the last one? So we should go for which one? When you're looking for R square, you go for the highest or the smallest. Huh? So, we go for the highest or the lowest? The highest. So, the highest is equation 1 and equation 2. See there? Yeah. The highest. Then standard error of estimate. The first equation has a standard error of estimate of the second one, the third one, and the fourth one. So which equation do we prefer? When you're looking at errors, do you go for a relationship that has many errors or fewer errors? Huh? These things are very practical. So, which one now has the fewest or the lowest? This equation number 2, eh? Yeah, equation number 2 is the one that has the lowest number of errors. That's all. So going by these results, you can see equation 1 has scored 2 out of 3. It has scored here, it has scored here. Even this one has scored also 2 here and here. So they are tied. That's all? They are tied. Kila mtu amepata 2 out of 3. So who do we go for? Number 1, now that here they were equal, you disregard this one. This becomes irrelevant. It becomes irrelevant. Then you now ask yourself, between the independent variables and the error, who is more important? Yeah. Between the number of independent variables and the error, which one should guide you more? Huh? We have just said that a while ago here, when you ask many people, you are now reducing the probability of making an error. So the number of independent variables comes in to reduce the error, but the error does not reduce the independent variables. So the independent variables are more important. So we just make a comment down there. From the above results, the most reasonable equation from the above results, the most reasonable equation is equation 1. Since it has the highest number of independent variables. Since it has the highest number of independent variables. Yeah, so that is how you provide that answer. Then number 2 says, determine if the equation provides a useful prediction. So we are told to determine whether the equation, obviously now that is equation 1, equation 1 provides useful prediction. Useful prediction. You determine whether the equation provides a useful prediction. Now, anytime you see a question asking you about the equation, you should always do the F-test. You should do the F-test. F-test is the one that determines the usefulness of the equation. Okay, so I was saying you do F-test, but unfortunately this question has not given us F. So if you're not given F, the next thing that we can talk about is checking whether the assumptions have been maintained. Assumptions are the ones, remember we said the assumptions ensure that the findings are accurate and the conclusions are acceptable. So for the findings to be accurate, or rather for the equation to give us a useful prediction, the findings must have been accurate. And for findings to be accurate, the assumptions must have been maintained. So, I think because the matrix is seen, so you can see the correlation coefficient matrix. Can you see it? The correlation coefficient matrix. Or we have to redo it here. See, it is very clear there. Yeah, it's very clear. And you can see the relationship between labor and materials and labor is 0.3489. You can see 3489. And then orders and labor 0.24. And then orders and materials is 0.1324. So none of them is greater than 0.8. Can you see that? None of them is greater than 0.8. And if none of them is greater than 8, so instead of drawing the, so this is what you shall write. The equation will provide a meaningful, or rather a useful prediction, since the following assumptions have been maintained. Since the following assumptions have been maintained. The following assumptions have been maintained. 1, linearity. Maybe we can explain kidogo. The equation is of the form y is equals to a plus bx. The equation is of the form y is equals to a plus bx. Number 2, independence of independent variables. Independence of the independent variables. And we explain none of them, and maybe into brackets, we can list those ones so that in case you're not very sure. We are talking of these 3, 4, 8, 9, 0.242, and 0.1324. None of them, those 3. None of them is greater than 0.8. None of them is greater than 0.8. Okay, so that is how you are supposed to answer that question. Now for the last one, I don't know whether I told you to do some assignment on the advantages of forecasting or the benefits. If I did not, then you will do that as the answer to Roman 3. Roman 3 has to do with the advantages of forecasting. So once you are through with that, you will also on your own now attempt the question of May 2018, question 2B. The question of May 2018, question 2B. May 2018, question 2B. May 2018, question 2B. Now from there, the next agenda is called, or the next method is called running curves. Running curve methods. Running curve methods. Running curve methods. And we write that this is a forecasting technique. This is a forecasting technique based on the concept that as a task is performed, over and over again, the time taken to complete, gradually declines, and the quality of output improves. First of all, it is an exponential function. Which is expressed as an average or total function First of all, the decline in time is noted only at double points. First of all, it can be illustrated as follows. So this is total, and y is equals to ax raised power b plus 1. And this is average. Is given as y is equals to ax raised power b. K here. This is x-axis. This is y-axis. This is y bar 1. This is y bar 2, which is r. Y bar 1. This is 0. This is x1. This is x2, which is 2x1. So that is how a running curve is illustrated. And what we are saying, when you start to do something, you take a lot of time before you complete it. But as you do it over and over again, you find that quality is improving and you take less of time. So when that happens, we say that the worker is improving or is running. And that improvement is only visible at double points. That's why you can see this is, I need to say these are units. These are units and this is time. That is time, that is on that side. So the average is y bar. So we have the two approaches. So those who are online, and say you have logged in using two gadgets, log out one. Be fast. through. Okay. Where, down there, where y equals total time, y bar equals average time, Now, there is something you can see here, the way y and this one is written. This one has a bar, and this one does not have. The one with the bar is the one talking of average. The other one is the total. But the bar is not the differentiating character or differentiating reason. There are times you will get both written like that. So how you know which is which is by looking at the formula. The formula is the concept. You see, the y bar has just b, but the total has b plus 1. So what makes it total or average is the power here. So it's not just this one, because there are sometimes you will not get this one. Okay. A, time taken to complete the first unit. A is time taken to complete the first unit. Time taken to complete the first unit. X, cumulative units. B is called running index. Running index, which is usually given as the log of R, you divide by the log of 2. B is the running index, which is given as the log of R, you divide by the log of 2. And this R is running curve index. Running curve, sorry, not running curve index. This is running curve rate. Index is V. Running curve rate. Then K is called the steady state. Steady state. Maybe we could specify kidogo. That is point at, or rather minimum time required to complete the task. Minimum time required to complete a task. Now, if you look at what you're saying here, with the average, as you do more units, the time taken gradually declines. Obviously, the total goes up, but at a decreasing rate. But it cannot go all the way to become zero. So it will come to a point here where it will stabilize. And actually, in practice, once it gets here, if you continue doing more and more, you start now increasing. It starts going up. I don't know whether you have gone to the library and at the beginning you are understanding everything and not taking a lot of time to complete a page. After a few minutes, the page is done, you go to the next one, you go to the next one. Then it comes to a point when it is time to turn the page. Before you turn, unarusha macho pale juu, what you see at the top of the page, unashangaa kama umesoma. But it's time to turn the page. For sure unajipima, unaona ni kama sijasoma, unajiambia wacha nirudi nisome hii page tena. Tena unaanza, kabla ufike hapa chini tena umepotea. Then unang'ang'ana, so you find it is taking more now of time to complete one page. And when that happens, it means your mind has already come here. Sasa you are taking a lot of what? Time. And it's time to take a break. Otherwise, you are doing nothing. So my point was, it cannot come that umezoea kufanya kitu such that you can now do it with zero time. It is only God who can do with zero time. But for the human beings, you improve, alafu inafika mahali where you stabilize. That something must be done with some minimum time. Na ikishapita hapo, then you start to increase. Okay. The next thing is assumptions used. Let's discuss assumptions. 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 Number one, the workers are highly motivated. The workers are highly motivated. The workers are highly motivated. Point number two, the labor involved is direct. The labor involved is direct. Another one is sufficient data has been gathered. Sufficient data has been gathered. Sufficient data has been gathered. The number four is that there are no breaks. There are no breaks. There are no breaks. Yeah, those are some of the assumptions we make. Then the next thing that we need to mention briefly is called stoppage of running. Stoppage of running. At what point do you start? Do you stop running? Or understanding? Stoppage of running. A few issues. One is demotivation. Demotivation. Another one is fatigue. Fatigue. Another one is breaks. Breaks. Another one is change in technology. Change in technology. And methodology. Methodology. Change in technology and methodology. The last item that you need to write down is applications of running curves. Applications of running curves. Applications of running curves. One, forecasting of costs. Forecasting of costs. Number two, setting of selling prices. Setting of selling prices. Number three, performance measurement. Performance measurement. Another one is budgeting. Budgeting. Another one is project appraisal. Projects appraisal. Another one is standard costing and variance analysis. Standard costing and variance analysis. Standard costing and variance analysis. Another one is competitive bidding. Competitive bidding. Competitive bidding. So, as you can see from that list, running curves is very, very popular. And actually, most of those applications we have noted, they are some of the topics that we shall be discussing. So, if there is, or rather, that tells you running curves is very, very important as far as this subject is concerned. You will keep on seeing it in very many topics as you go by and by. Now, coming back to the assumptions, when you are doing running curves, there are some basic assumptions that must be made. And one of them is that the workers must be motivated. Motivation has to do with happiness, has to do with liking. If you like something or someone, if you are happy with something or someone, chances are very high you run from them. And the opposite is true. That's why when we have mentioned about stoppage of running, we have said when people are demotivated, you don't run. If you are unhappy with me, chances are you are not understanding what I'm saying, or not necessarily unhappy with me. If you have come to this class unhappy for various reasons outside there, umekuja na hasira zako ama mambo yako inakusumbua, then you are not following what I'm saying. You are just here mechanically. Demotivation makes people not to be productive. I'm sure you have gone through such moments in your life at one point or the other. And there are those days you feel so low. Even you go to the workplace and you don't want to associate with anyone. You just want to be somewhere in your own corner, doing your own things. And those people that you don't want to see, they have nothing to do with your issues. Then there are days you are so happy. You want to go saying hi to everyone, not in a bad way, but because of the happiness. And some people even do not know why you are so excited. So motivation makes people to run. And on this note, in Kiswahili they say, usitukane wakunga, eh? Is it wakunga, eh? Yeah, kama nini? Kama uzazi, ungaripo. So the same applies even in a class like this one. As long as you are under my hand and you have not passed A and B, make sure you always like me, whether I'm likable or not. Even when I close your eyes, ensure you still like me until you pass my paper. Right? Yes. Because when you like me, you will always be looking forward for my lessons. Ikifika 6:14, unaanza kuangalia mwalimu kwani hakuji. Because you are looking forward to meet me. When you finally see me here, some happiness inaingia kwa moyo wako. And even as I continue teaching, you continue absorbing what I'm saying. Even when the going becomes tough, I'm speaking here and you're getting nothing. You don't start saying, huyu mwalimu nasemanga hatukufunza hii. You don't start saying that. What you do, you put more effort so that you don't disappoint a person you like. And eventually the end result is that you will pass. But on the reverse, if you develop a negative attitude against me, then what will happen, itakuwa inafika Tuesday asubuhi, unasema hii leo ni Tuesday ile siku ya kimani. Unajikokota tu, unakuja finally. Then you start wishing, siachelewe, why is he coming very early? Then sitachelewa 6:15 I'm here. When you see my head here, kichwa kwa tumbo unasikia kwa. Because kuna chuki ndani yako about or against me. Now as I continue teaching, instead of you listening to what I'm saying and the good things that I'm saying, you are already keen to note the mistakes that I'm making, how I'm pronouncing some words, how my figures are not working. And when the things become tough, you even start telling your colleagues, sinawaambiaga Kimani si mwalimu mzuri, Kimani hajui kufunza, huyu jamaa atafanya tuanguke. So you are already seeing the negative things. So when you have a negative attitude, you cannot retreat, you cannot run. So anywhere you find yourself running or being taught, ensure you like the environment, you like the people teaching you until you pass. I'm not in any way saying that teachers should be allowed to misbehave and mistreat people, but I'm just emphasizing that is important. And for some reasons, tukikosana na wewe, just hold on until you pass EMA. Sasa ukishapita, then unaweza tembea hapa uniite kwa corridor niambie Kimani kuja hapa. There is one or two things we need to sort out. And we have a lot of evidence that we can show of people who quarreled with teachers and they did not perform well. So, uhakikisha unapenda walimu wako. Not only Kimani, any teacher you find yourself under, ensure you like them until you pass their papers. Good. I think the other thing that I needed to say is the workers, there should be no breaks. There should be no breaks. When we take breaks, actually what happens, the mind of a human being is like this. This is the forehead, and this is the forehead. The forehead inaitwa conscious. This one inaitwa subconscious, and this one inaitwa unconscious. When you see something or someone for the first time, your experience inakuoga hapa kwa kichwa, hapa mbele. Then inaanza kuingia ndani. Inaanza kuingia hivi. And the rate at which inaingia huku is a function of several things. One is the period of exposure. Uko na huyo mtu for how long. Number two, your age. When we are young, kichwa haikuwagi imejaa vitu mingi. But as you age, unaenda ukijua mambo mingi sana. That's all. So kichwa is not expanding. So inaenda ikijaa. So kama imejaa, si sasa kuko na material, you cannot move easily. You see, like now this room is full of chairs. You cannot just run. That's all. But if it was empty, you can run very fast and you find yourself in that corner. So as you age, unaendelea ukipaki mambo mingi kwa kichwa. So any new material being pumped, it is rolled down. The other factor is the issue of time. The issue of time. In the morning, the head is normally composed. You know what happens? Kichwa inakuanga ni kama iko na vitu zimewekwa ndani. And in the course of the day, kama sasa venye tumeanza siku leo, nimeanza kuchokora hiyo kichwa yako, nimeanza kukusugua. So inaanza kuchemuka pole pole. Tukimalizana hapa uende kazini, uanze kusuguliwa na watu wengine, ianze kuchemuka. Iendelee hivyo in the course of the day, inachemuka. By evening, ishachemuka imejaa. I hope you're able to visualize. Imechemuka, kichwa imejaa. And I'm sure you normally experience this. Times unafikia kichwa yako haitaki anything, haitaki kuongea na mtu. Even myself, at times I go to the house, I tell everyone to switch off every gadget, mpaka TV. Because nasikia kichwa imefanya nini? Imejaa. I just want a very quiet environment. And then when you go to bed, unaamuka ukiwa sawa. Unasikia kichwa now, it is not as heavy. So what has happened, zile vitu zilikuwa zimechemuka zikajaa, they cool down, zimeshuka ziko somewhere here. So hii space yote ya tu iko empty. So ukikuja asubuhi tuanze kupump material like what I'm doing, inapitia huko juu inaenda haraka. But wale wanakuja jioni kichwa itakuwa imejaa. So nikipump material inakuwa blocked. That's why you people in the early morning, I teach you 3 hours. Your colleagues in the evening, I teach them 6 hours, and you are at par. How? And it's not that I do fewer questions. It's because you are very fresh. You understand it very fast. But wao wajioni, by the time wakuja hapa, hata mimi nishachoka. Wao wamechoka. So tunajaribu kuongea kitu which is taking a lot of time. Yeah. Okay. Now, my point was this. If anything has not reached here, the unconscious, if it has not reached here, if you no longer are exposed to it, that's why you hear out of sight, out of mind. Out of sight, out of mind. Now, these two, which we are calling running, is what in academics we call cramming. By the time you go to the exam, nakuanga umekram, hiyo material nakuanga hapa na hapa. That's why when you take a small break right now, when you mlikuwa kwa break kidogo, mkikuja hapa nikiwaambia msome T-table unashikwa. Na hii ni T-table ulikuwa unasoma QA juzi na ukapita. But because there was a break, hiyo time hauko unasoma, ikaanza safari. Ikarudi. Now tumeanza kuirudisha. So if you prolong that period ifike hapa, you will never forget. By the time ifike hapa, sasa tunasema uko na experience. Now most of the things zenye zilifika hapa, they influence you whether you like it or not. Now these are things that you were taught when you were young. Hizi ziko hapa tumejua tukiwa wakubwa. Na huwa zinaharibika because of time. Huwa zinakuwa distorted when you are threatened or when you are fearful. Naona kama sasa hivi venye tumekaa. If you are to see danger, real danger, your mouth will speak which one? Mother tongue or Kiingereza? Assuming Kiingereza is your mother tongue. It's not your mother tongue. The word that will come out of your mouth is in mother tongue. Because danger distorts hii kampango. Hii kampango what remains forever. That's why you hear, ukikosana na mtu, na uanze kuona maneno sasa haitoki vizuri. They start speaking in mother tongue. Huyo mtu amefika. Everything here is destroyed, reasoning, that's hapa. And you should run away because that person now is at the peak. It's the same thing when you go to the exam. I don't know whether you have experienced this. Asubuhi or a few minutes before the paper, kuna mahali mkuu unasoma and they had written 7 points. Na ukasoma vizuri. Then umeingia kwa mtihani, the question requires 4 points. Unajaribu kukumbuka, none of them is coming. All what you remember is that ulikuwa unazisoma lakini ukumbuki ni gani. Unangangana. When they say exam is over, pens down, those points start coming one by one. Have you ever experienced that? It's because ulipoingia kwa mtihani uoga iliingia. Sasa huo uoga ukaharibu wote wasikia. That's why it's advisable when you go to the exam, you start with the easiest question. When you start with the easiest question, inakujaza furaha. Hiyo furaha it waters down the water and you come back to your normal senses. Na sasa points inaanza ku flow. Lakini ukienda uanze na swali gumu, uijaribu uone kweli imekataa. Unajua kuna maswali unafanya na unaona hii kweli imekataa. Na saa hiyo imekuchukua 48 minutes. Na bado haitakubali. Sasa ukichanganya na ile uoga nyingine, that paper you are as good as finished. Yeah. So let's do some questions. I wish I had time to discuss more, but now let's have an illustration. And maybe I also need to say, one of the reasons why people do not become experienced, Nancy, we will do that. One of the reasons why people do not get experience is because of high mobility, especially when people are young. They are very mobile, like at your age. If you remember when you came to Nairobi, you are not brought up in Nairobi. The first 2-3 years, how many houses did you move to? The rate of movement compared now with now, is it increasing or decreasing? Yeah? It is decreasing. So unapata those days umekaa mahali maybe 1 or 2 months unahama. 1 year unahama. But with the time unajipata umekaa mahali sasa hauna haraka ya because they go with age. When someone is young, they are so mobile. The same thing happens with jobs. Most likely some of you are in your 2nd, 3rd, 4th, 5th jobs. But as you age, you will go settle. The reason as why people are so mobile is because of disconnect between your dream and the reality. Dream is what you thought you would get and what you are actually getting. Like now that you are in school, you are in section 5. I know your head is full of dreams. Nikimaliza tu sec 6 hivyo. Sio kitu unaijua. Ukimaliza tu sec 6. What will happen to you? Hey, hakuna mahali unajiona after sec 6. Si unajiona in that big company, that big job, driving the top of the age car, living in the posh estate because you'll be a qualified accountant, a lot of money, hizo vitu unaziona. Ni vizuri kuona. But take note, it is not a matter that they will always come or they will come immediately. So sasa when they don't come, tuseme for example unajiona ukifanya kazi kwa bank, and I'm not saying working in a bank is the best. When you graduate, you don't get a job in the bank, you get in a hotel. Neither am I saying working in a hotel is the worst thing. So ukiwa kwa hotel, you cannot settle because your destiny was not in the hotel, it was in the bank. So unajaribu tu kutoka kwa hotel uende bank. So you keep on changing. In the process, badala ukitoka kwa hotel, instead of getting a job in the bank, you get a job in a flower farm. Like Naivasha flower farm, Mama Del Monte. Ukienda huko kwa shamba, that was again not your destiny. Macho yako bado iko kwa bank. So ukiwa huko bado unangangana, then from there, instead of getting a job in the bank, they give you a job somewhere in a hospital as an accountant. So hata huko you will settle. Tena unakuja, yeah. And as you do these things, miaka nayo bado inasonga, ndio? Miaka ikisonga, you know society has some expectations. Maybe you get married or you marry. Sasa ukioa ama ukiolewa, you are married to someone who is not your brother or your sister. Those of us who are married know what I'm saying. Unaanza kusuguana, mwelewani. Wewe unaenda huku na yeye anaenda huku. Kama unaargue hivi. So kabla mwelewane, mwaka mmoja imeisha. Hiyo mwaka ikiisha, Mungu atuwabariki mtoto naye ndiye huyo. You have never been a mother, you have never been a father. So sasa unaanza kusuguana na mtoto. Mtoto akilia kidogo hospitali. Nafikiria ni mmoja. So kitambo uelewe mtoto wa kwanza mbele yako, wa pili ndiye huyo ameingia. Before you know, umeenda kindergarten. You have joined the parents teachers what association. Hiyo ni school fees tena umeanza. So unaangalia maisha iko na so many what disruptions. So you don't get to settle to learn. And that's the reason why people keep on moving from one place to the other. Good. So illustration. So that is the kind of a table I want us to use as an illustration. Let's be fast. Let's be fast. Okay. So for the first one, we come on there. Then this one now should be 60 times 1 raised to power minus 0.322. Give me the answer. The answer is 60. Yeah? Then for this one, this formula, for the first unit, you just take A. So you just write 60, the way it is. So that one has no working for the first unit. Then here, it is going to be 60 times 1 raised to power 0.678. What we are supposed to do, those who are not getting 60, once you take 1, you raise to this power. Then you say equals. What you get, you multiply by 60. That's when you get the answer. So this one is both of these are units. These are units. These are units, not limits. The answer is 60. Yeah? Now this formula says you get x, which is 1. You multiply by the bar 16, and the answer is what? 60. The answer is 60. And let us go to 2. Let us go to 2. So now tell me 60 times 2 raised to power minus 0.322. You're getting 48. 48, can call it 48. Then on this side, this is now the first time you are able to use the formula. it says you get R multiplied by YT to get YT plus 1. The meaning of this is for you to get the one that you want, you take R multiplied by the one that was above it. So it will be R, which is 0.8. The one that was above is 60. And the answer is what? 48. The answer is 48. That's the meaning. Huyu mwingine, we will say 60 times 2 raised to power 0.678. So 2 raised to power 0.678 multiplied by 60. I'm getting 96. And call it 96. And then this one, you take 2 multiplied by 48. And that again also gives us what? 96. That gives us 96. Let's do the same for 4 with 4. Now with 4, it will be 60 times 4 raised to power minus 0.322. So 4 raised to power minus 0.322 times 60. We get something to do with that 8.4. Down there, that 8.4. Is it? Okay. Then this one I have said according to this formula, you take R, which is 0.8, you multiply by the preceding. The preceding is 48. So multiply by 48. You multiply by 48. And when you multiply by 48, you say 0.8 times 48 is also 38 point what? 0.4. 38.4. Then on this side, you will say 0.8 times, not 0.8. Shall talk after 0.8. It is 60. 60 times 4 raised to power 0.678. So 4 raised to power 0.678 times 60. 2 decimals or 1 decimal, 153.6. 153.6. Then 60 times, not 60. I'm supposed to change the unit now. That is 4 times, or 4 is 4 times 38.4. So 4 times 38.4 is 153.6. 153.6. Nancy, the formula says R 0.8 times the preceding. Hii 48, hii ndio ilikuwa hapa. Preceding ni ile imetangulia. So hii 60 inatumika hapa, hii 48 inatumika hapa. Hope you are able to see that. Do the same for 8. Down there, let's go to 8. Let's go to 8. Let us go to 8. So when we come to 8, it will be 60 times 8 raised to power minus 0.322. So 8 raised to power minus 0.322 times 60. I'm getting 30.72 That's all. And then here I will say 0.8. So now you can see this one. It is 0.8 multiplied by the one that was above it, which is 38.4. 38.4. So if you take 0.8 times 38.4, that also gives us 30.72. 30.72. And then this side, it will be 60 times 8 raised to power 0.678. So 8 raised to power 0.678 times 60. I'm getting 245.72. And then here I will say 8 times 30.72. So 8 times 30.72, I'm getting 245.76. 245.76. Now, there are several things that I want you to see from this table. One is what we began by saying, that the learning curve is two approaches. There is the average and there is the total. So when you see the question, the first thing is to know, are you dealing with the average or total? Then the second thing you can see is that for each, we have two formulas. For the average, two formulas, total, two formulas. It is important to note all the formulas because there are some situations where you can only use a specific formula. Now, in that case, this one, we call it the universal because it's applicable everywhere. This one. But for this one, it is only applicable in double points. Double points is what you have seen us do there. Saying 1, 2, 4, 8. Now you can continue to 16, 32, and 64. These are the double points. So this formula only applies at double points. If a value is non-double include, like now here we have 3. Still. Here we have 5, 6, 7. Those are non-doubles. Here we have 9 all the way to what? 15. Those values are non-doubles. Here we have 17 all the way to 30. So if you're looking for any of these, these formulas are not work. That formula cannot work. The next thing that you should be able to see, if you look at these averages, the answers to the pattern, we began with 60. When we have gone down, the time has been decreasing up to when now we are in number 8, and it is taking us what? 30. It's taking us 30. That's why it is very, very important to work with experts. Experts take a shorter period and they give you a high quality. Like now, you have made a very good choice of coming to Destiny where we have experts who will be able to complete the syllabus and still give you the best quality. Check out many other places they will not complete the syllabus. Because when you have done something over and over again, it takes you lesser time and the output is of high quality. But mtu anajaribu ajui what to do where. Good. Now there are two things that we still need to do. So I want you to draw a line here, like we have come to the end of the table. We have come to the end of that table. Let me first of all say that, so that you are able to follow what I'm saying. You draw a line to show that you have come to the end. Then when you have drawn the line to show that the table has come to an end, you extend this line, this one in there, and this one, and this one. So the table now has 3 columns. Shaandika hivyo, we have continuous interval. Continuous interval. Continuous interval. Now the continuous interval is a situation where you are told to get now some units. Like if you are told to get the time of making 10 to 18 units. That's an interval. 10 to 18. 10 to 18 units. Nancy, this is an illustration. It's an illustration. So just copy what I'm giving. When we have a question, you will see them clearly. So 10 minus 18, or not minus, going to 18. Now this one is given like this. I think y bar for the first 18 minus y bar for the first 9. That is how it's computed. If you are told to get the time to make 10 to 18 units, is y for the first 18, y bar, minus y bar for the first 9. So this one, it will be 60 times 18 raised to power minus 0.322. Then you minus 60 times 9 raised to power minus. So this one, utafanya baadaye, because naona time is going to kuisha. You'll get the answer later. Yeah. Then tukuje hii side, y for the first 18 minus y for the first 9. For the first 9. So here utasema ni 60 times 18 raised to power 0.678 minus 60 times 9 raised to power 0.678. So ukimaliza hiyo, chora line to show that hiyo iko kando. Draw a line. Draw a line to show that we are through with that. Tutafuta like values later. This will be very common in our workings, in the questions that we shall be doing. That's why I'm only giving you one, just to see how it's done. But it will be very common. Haya. Sasa ukishachora line, we need one more like this one. One more, sasa huwa inaitwa continuous marginal. Continuous marginal. Continuous marginal. Let me explain it though, because this will also be very, very much applicable in computations. You can see I've given you 3 divisions. Kuna moja tumeita specific, kuna ingine tumeita continuous interval, na ingine tumeita continuous margin. Now it is specific, or something is specific if the first unit to be made is among the units that you are computing for. Ile ya kwanza, it is among the units. Like what now we are doing, like when we have this 8, the first unit is part of this 8. But if the first unit is not part of the unit that you are dealing with, it is continuous. Naona kama hapa tumesema 10 to 18. So tunaanzia 10. So tukianza kuchukua 10, the first one ile ilikuwa ya kwanza is not part of what we are interested in. Umeona? So that is continuous. Then in this one that is continuous, you also check, do we have just one unit or it's more than one unit? If it's more than one unit, inaitwa interval. Like from 10 to 18, that is more than one unit. So hiyo inaitwa interval. Lakini kama it's just one unit, that is called margin. For example, if we are told to get the time of making the 7th. So the first unit is not part of the 7th. And 7th is just one unit. So hiyo inaitwa margin. So sasa hii nayo utaargue namna hii. It is just the same thing like huyu mwingine. So in the argument, you would say, for the 7, it is y for the first 7 minus y for the first 6. Ndio tuachiwe 7. So then this would be 60 times 7 raised to power minus 0.322. You minus 60 times 6 raised to power minus 0.322. That way. Alafu sasa ukikuja huyu side nyingine, y for the first 7, y for the first 6. So this will be 60 times 7 raised to power 0.678 minus 60 times 6 raised to power 0.678. The final comment that I'll make, ukitaka kuelewa swali ya running curves, hakikisha hii table umeelewa kabisa. Take a lot of time and read this table. And anytime you come across swali ya running curve na unaona inakulemea, always come back here. This summarizes everything. It summarizes the 2 approaches, the 4 formulas, and the 3 applications: specific, continuous interval, continuous margin. And as I said earlier, running curves is something we will keep on fighting in many topics. So the earlier you make peace with it, the better. Thank you. We call it at the other juncture, and we meet in the next lesson.